This is video 841, and the goal here is to be able to find and use multiplicative inverses. So we already talked in class about how to find them for a 2 by 2 matrix. In this video, we're going to look more at a 3 by 3 and beyond. So remember that we talked about this process where if you have these three, so we're trying to find the multiplicative inverse of the matrix down at the bottom here. And it's as simple as doing the same row operations as we used to do and getting the left-hand side to be the identity, but we have to make it a matrix with the identity on the right-hand side as well. And it has everything to do with the systems of equations that would be formed and then the processes that would have to happen in order to find it. So yes, your calculator does all this for you, but the whole goal here is for you to understand what's going on behind the scenes and what the program is in your calculator that is happening when they're performing this operation to get the multiplicative inverses. So in general, the way that we're going to talk about this is to find the multiplicative inverse of an invertible matrix. So it has to be a potential matrix that can actually be inverted, meaning it has an inverse. You simply start with an augmented matrix with A and then the inverse, the identity matrix. This is A. And then the other side of the augmented matrix is the identity that's the same size as the matrix A. Remember, A has to be a square matrix, so 3 by 3, 4 by 4, so on. And the identity will be the same size as the original matrix. Then the simple step that we do is we perform row operations to turn the equation into the opposite. So now we want to turn it into having the identity on the left and some matrix B on the right. Okay, some matrix B on the right. So we're going to do the same Gauss-Jordan elimination process to get the reduced row echelon form in order to move things around until we get the identity on the left and then a matrix on the right. That resulting matrix B is in fact the inverse. And a simple thing you can always do is verify that it's the inverse by performing that multiplication. If I do A times B, I should get the identity matrix. And vice versa. If I did B times A, that should also give me the identity matrix. So there's a quick way to check your answers, calculator or by hand as well. So let's take a look at an example. So to find the multiplicative inverse, we start with our matrix A, and we make it an augmented matrix by adding on the end the identity matrix. Okay, so now my goal is to make it look like the identity on the left and some matrix on the right. So it doesn't matter what's on the right, what's important is I get the zeros and ones on the left. So I'm seeing some steps that I can take here. It looks like I could add row 1 and row 2. First of all, row 1 is halfway there. It's got the 1 where I want it. But if I add row 1 and 2, and replace row 2, then row 2 will also have that 0, and it'll be halfway there. So let's perform that operation. So the top row will stay, and the other row is going to be replaced with 0, 4, 4. Oops, I got to add the right-hand side as well, just like we've been doing before. Just adding the 1 and 2 together. Sorry, that's going to be a 1, 1, 0. And we'll just copy the other row down because it had nothing to do with the first row. So the first column, excuse me. So the first column is done. I like those common 4s because those make it seem like it's going to be easy. I want to create a 1 right here. I'm sorry, a 0 right here. So I'm going to perform the operation row 3 minus row 2. And that's going to replace row 3. Okay, I'm going to leave the other rows behind for now. But that's going to get me my 0. I'm going to leave row 2 alone as well. But I'm going to do row 3 minus row 2. So I'll get my 0, 0, negative 1, negative 1, negative 1, 1. Okay, so that's my matrix on the bottom. My bottom row is almost done. I would simply have to times everything by negative. Had I looked ahead, I would have seen that it might have been smarter to do row 2 minus row 3. Then I would have gotten the 1 in this spot. It would have turned that into 1 instead of going the other way around. But no biggie. I got my result after just timesing by -1. So far I have the bottom row is done. And the bottom row will definitely help you with the other rows. Especially the one right above it. I want to get rid of that 4. The 4 that we see right here. And so to get rid of that without changing the other stuff that I like is I'm going to do the middle row minus 4 times the bottom row. So row 2 minus 4 times row 3. And that will create a 0 where I want it, and that will go where row 2 is. And we'll replace that, and then we'll see where we're at. So let's see, I'm going to leave row 1 alone. 1, 0, 0. Zeros are going to stay. Row 3 is going to be left alone as well. In fact, row 3 is done, and I can actually see 3 of my answers to my inverse. And I'm going to do the middle row minus 4 times the bottom row. So it's going to give me 4 still. It's going to give me a 0. So I'm doing 4 times this, really a -4, because I'm subtracting. That's where I get my 0. I get -3, -3, and I'm going to get 4. Okay, so there's my result. So now I'm going to divide everything by 4 in that middle row so that I can have a matrix that has a 1 there, because that 1's going to be much easier to help me take care of the top row. So we want to keep an eye on just our fractions and just being a little more careful at this point, because we're now going to have fractions. So I'm just dividing that row by 4. So I'm going to have -3/4, -3/4, and 4. And the bottom row is the same. Okay, so the middle row is also done. I can see 3 of my answers. And then last but not least, I'm going to look at getting rid of that 1 in the top row that I don't want. So to do that, I'm going to take the first row and minus the second row to replace row 1. So row 1, let's see, so I'm going to take away this second row. So I'm going to change all these so I can see what I'm doing. And let's see, I'm going to have 1, 0, 0. 1 plus 3/4, so 1 3/4, 3/4, and -4. And then I'm going to copy the original middle row down again, the +1, -3/4, -3/4, and +4. And the bottom row. Okay, so there is my inverse. Okay, yes, I can simply punch into my calculator and verify that this is the correct inverse if I'm not sure. The inverse matrix that I have found here is the matrix. Feel free to use decimals. These are fine decimals to use, so you could call it 1.75, 0.75, -4, -0.75, and so on. But apparently this is my inverse matrix. That will be the inverse of A. Okay, so those key things that we've talked about with getting into reduced row echelon form, it all exists here. Notice a couple of things that I've said in class, but I think some people still haven't seen or noticed. I don't like to divide until the very end, so I left that 4 alone until it was absolutely necessary, partially because writing fractions takes more work, partially because I make more mistakes with fractions. So if I can leave it with a whole number as long as possible, I'm better off. Okay, so these zeros at the beginning are super important, these zeros that we found right away at the beginning, because they slowly help me eliminate the top row. So notice the top row is typically the last thing that you take care of, because once the lower rows are done, the top row is much easier to deal with, because they can quickly eliminate things without changing the 0 that already existed. For instance, in row 1, that 0 would have been impacted by the previous rows had I tried to take care of that 1 up here. and I want to try and keep zeros. So I left the top row alone, and usually that's the last one you deal with. As long as that 1 is there, you can deal with the top row at the end. Okay, so those are some hints, but we are going to do a few of these by hand because it is important to understand what your calculator is doing rather than just blindly plugging things in and not making sense of the math. So let's take a look at how to solve a system. So this is something that you saw in Algebra 2. This is how you learn to solve systems. And systems, we're talking about a system, a matrix AX equals B. This system has a unique solution, a unique point where they intersect if A has an inverse. Okay? So the simple thing that we're going to do is multiply both sides by A inverse. So here's what it looks like. If we have this linear system with X, Y's, and Z's, and we turn it into a matrix, and this is a different matrix than the augmented. It's a matrix of the coefficients times the matrix X, Y, Z. Because remember, when we multiply matrices, we do row times column. So that row and column would create my first part of my linear system that has to equal 2. And if I did it again, row times column, that would create the second linear equation for my system. And continuing, et cetera, same thing along the lines. So this is a different way to write the matrix that you've seen before, most of you. So it should be somewhat familiar. So A is the coefficient matrix, X is the variable matrix, and B is the constant matrix, the results, the answers. So the simple way we're going to solve this is what like you've already seen. We're simply going to take the inverse of both sides, not the inverse of the actual numbers, but we're going to put the matrix A inverse on both sides because A inverse times A will create the identity matrix every time if A has an inverse. And that means X will truly be alone, and I can see my solution on the right-hand side of my equation. Notice a couple of things. Notice that A inverse was multiplied in the front of both sides. Order matters, so you need to make sure you put A inverse in front of both sides, not on the left and on the far right. Both on the left, both in front of what was normally there. Okay, and then that's what we would plug into our calculator to tell us the answer. But this only works if AXB has a unique solution, which is why our other method for solving systems is so crucial. We've seen ones that don't have a unique point, but have a dependent system or an inconsistent system, and we need to know how to solve those as well. So if this method doesn't work, you have to go back to the other one. So this is one option for solving systems that you can give a shot to. We'll quickly buzz through this one and then let you try your checkpoints. So it's as simple as writing the coefficient matrix 1, 1, negative 1, 0, 2, 1, negative 1, negative 2, 1. This is the A matrix. The X matrix is always going to be your variables in a column format. That's your X matrix equals B. And B is always your constants, your values that these three quantities are equal to. Now what we plug into our calculator is A inverse B. Of course, we'd have to pull up the matrices using the keys on our calculator, and we would use the inverse key. Okay, but it has to be plugged in that order. It can't be B, A, inverse. It would not give you the same result. Okay, because order matters when you're not multiplying a number by its inverse. Okay, this is not the inverse of B, it's the inverse of A. So we plug this into our calculator, and out will come our result. So take a moment to try and enter that in your calculator. I'm going to do the same, and then we'll check in with the result. So you plug this in your calculator, it should output the matrix 14, negative 3, and 9. So that is the solution for X, Y, and Z. And there's your answer. So this is another way to plug it in. It requires plugging in two matrices. Is it more work? Is it less work? I don't know. You'd have to count the number of buttons you have to push. I'm pretty sure it's comparable to the work that we did in the past. So give these two a shot. Try to do this one by hand, number one. Of course, use your calculator to check, like it says. But see if you can do it by hand. Okay, see if you can get a few steps in. The numbers aren't too big. Hopefully they won't cause any decimals, but you can see if you're on the right track by using your calculator's inverse key. But number two, you definitely should be able to feel comfortable with if you set up the matrices correctly. So bring your questions into class.